What does it mean to factor? Yep. Oh, sorry, Alex, back there. To make something into multiplication. Okay, Josiah, is that a trinomial? How do you know? 3 terms. So if I have 3 terms, it is a trinomial. And we're going to look at something with trinomials that make them special when you're trying to factor them. Okay, what kind of problem is this right now? Is that a multiplication problem? No, it's an addition problem. Our goal is to make that addition problem into a multiplication problem because that's what factoring is all about. Okay? Now, I'm going to write up a problem, and I want you to tell me if it looks like that trinomial up there. Okay, so the first problem I want you to write is underneath it, x squared plus 7x plus 10. And when you write that down, tell me if it looks like the top trinomial. What do you guys think? Looks like it. And it doesn't have to be exactly the same because it's not, but does it look like it? You're like, how do you know? Okay, first of all, are they both trinomials? Okay? Are they both written in standard form according to the exponents? Yes. If you have a trinomial written in standard form, it's possible to factor it. So right now, is this a multiplication problem? No. We're going to go ahead and try that out. This is what I want you to write. I want you to write 2 sets of parentheses. And I want the parentheses to hold a binomial in each set. So I want each parenthesis set to hold a binomial. So you need 2 spots to be filled in. Okay, the process I'm going to go through is, it seems kind of random, but we're going to tie it back to the 4 methods of multiplying binomials. Who remembers the 4 different ways of multiplying binomials? What was that first way we looked at? Tabular. Good, tabular. Next we looked at vertical. Then we looked at distributed. Nice. Wow, you guys are quick. And then FOIL. Whoa. I really want to look at the FOIL and the tabular method. And I'll look at tabular method maybe tomorrow and after that. But we're going to look at how that relates to what we're doing here. Okay. So this is what I want you to do. I want you to be able to find out what fits in these 4 spots. And it's not like you can just put whatever you want. There has to be specific numbers. But here I'm going to give you a hint. The first spot in each binomial is always going to be that to the first power. And you're like, how does that work? Do you guys remember FOIL? What does F stand for? First. Okay? What's x times x? X squared. So that works, right? According to FOIL. So I got my first spot. But the real problem, or the real difficulty is what goes in here and here. Okay, this is what I want you to do. This is not tabular format, by the way, but this is a table. I want you to draw a little table here, divide into 2 columns. And you have to be able to write a few things in there, so don't make it too small, because then it gets really tight. You won't have to make this table for all the problems. In fact, on my lesson, I'm going to do it twice. Then I'm going to ease off of the table, but I want you to have good notes. All right, on the first column, I want you to label it factors of, and then I'll give you a number in just a bit. Factors of, and you're like, okay. All right, I want to pick a number, but I want to make sure it's a number that's actually going to help me out. Look at my trinomial here. There's something special about the last term, 10. Okay, 10 is called a constant. Does anyone know why 10 would be called a constant? What do you think? Yes?
Because it doesn't have a variable or an exponent.
Okay, it has no variable. It doesn't change. You're like, but this one, I mean, that doesn't change, does it? Well, doesn't 7x depend on what x is? What happens if x equals 1? What's this worth? 7. What happens if x is worth 5? This becomes 35. Doesn't this vary? What doesn't change? The 10. What about this guy? He doesn't change, does he? Well, it depends on what x is. So these 2 are variable terms, and this one's a constant. So I want to find the factors of the constant 10. I want to find factors of 10. You're like, I'm still not seeing why you get that and how you figure it out. Okay, we'll get to that. We're going to work backwards. Literally, working backwards. All right, the second column, I want you to write the heading, sum of factors. Sum of factors. Okay, before I move on, I have a lot of terms up here. We need to know what the terms are before we can move on, because you're just like, what is he talking about? Something I really want to drill into you guys is the different terms we use in math. Because you know what? Next year they're going to do this to you. Or sorry, next year I'll be doing this to you. But maybe 2 years from now and further, they're going to say this. The quotient rule for logarithms. And you're like, what? What's quotient referring to? Division, right? You should know that. And what's a logarithm? Exponent. So do you know what those two things mean? So at least you have an idea what they're talking about. You're not like, I have no clue. So somebody tell me what a factor is. What's a factor? It's a number that's being multiplied. You should know. If I say factor, think what operation? Multiplication. And then I use the word sum. Addition. Boom. Something's being added. Ready? We get the factors of 10, and then I'm going to get the sum of factors. You're like, okay, what do you mean? Can you guys give me two numbers that multiply to get me 10? 5 and 2. So I'm going to write here 5, 2. 5 and 2. Those are two factors of 10. And you could have said 2 and 5. Same thing. All right, give me another pair of factors that are integers. By the way, there are many decimal numbers. We're not dealing with that. Give me another factor pair. 1 and 10. That's another factor pair because 1 times 10 is 10. Anything else? Integers? No, we can go fractions, decimals. We're not going there. Okay, here's what I'm going to do in the second column. 5 times 2 gives me 10. What's 5 plus 2? 7. So you write that 7. You're like, okay, cool. And 1 times 10 equals 10. 1 plus 10 equals 11. Pretty random, right? What are we trying to do in this whole process? I want to find out what's here and here. We found it. Positive 5 and positive 2. What? Okay. You can write that down. You're allowed to write that down. Mr. A, I feel like I'm copying an answer and I had no clue how I got it. That's okay. I'll let you do it today. How did I get it? This is what I went through. I looked, it's kind of magical. What are two factors of 10? What's 5 times 2? 10. What's 5 plus 2? I want to get that middle number when I add those two factors of 10. Okay, but again, you're like, why would you want to do that? It's just like a pattern. Okay, how many of you know how to use FOIL? Distributed property? Vertical? Tabular? I want you to use any one of those methods and multiply these two binomials out. Go ahead and do it, please. Any method. Let's do it right. So you're like first, outer, inner, last, or distribute, or verticalize it. It's a word. And I want to tabulate it. Okay, fine. And add like terms. And please add them correctly. I have 2 people who maybe have it. 3? 3 people have it. 4? 5? Come on, pop those hands up if you have an answer. Okay, what's the answer, all of you?
X squared plus 7x plus 10.
Wait, did we just go in a circle? We did. We went through a circle. What's my answer? What are we trying to do here? What's the goal of this lesson? Factor trinomials. What does it mean to factor? Make it into multiplication. Which one of these is my answer? This is my answer right here. Is this a multiplication problem? Does this multiplication problem give me this trinomial? Then that's what works. And we're going to take that as our answer. And that's the process. That's all you have to do. Okay, how many of you saw some patterns there? You're like, oh, cool, I didn't see that. Did anyone see things like that? Like, oh, 5 times 2 is 10 and 5 plus 2 is 7. Anyone? No? Oh, yes? Okay. Thank you. It's encouraging when someone sees it. Go ahead and write this one down. We're going to do it again. We're going to make it a little bit less complicated because we got all the background info. All right, is this a trinomial?
Yes.
Is it written in standard form?
Yes.
Okay, we're good. So it is possible to factor it. And if I factor it, it's going to be 2 binomials. I have to fill in 4 spots, but thankfully, I already know 2 of them. What are the 2 spots I already know? Yep, I'm going to put x and x because x times x is going to give me x squared, the first term. That's right. That's what I get. Okay, great. That's cool. Fine. I need to find those next 2 spots. So what I'm going to do here is I'm going to create that table real quick. And again, on your homework, I don't expect it, but I'm going to do it for your notes. I want factors of what number? So I think I heard it. 14, the constant. I want factors of 14, and then I want the sum of the factors. I want the sum of the factors. All right, so throw out some factors of 14. So what times what is 14? Alex? 7 and 2. Any others? 1 and 14. Any others? Think. Come on, think in there. Get it. Get it. It's there. Got it. It's there. All right. You're going to notice in this lesson that there are a lot of like math facts. Like how many of you know that 2 times 7 is 14? Good. You should memorize that. It should be automatic. How many of you know that 1 times 14 is also 14? That should be like, that's just intuitive. But there are others. Negative 1 times negative 14 is correct. Because what's negative 1 times negative 14? 14. And there's got to be another one then. Negative 7 and negative 2. Now, in this problem, it might seem unnecessary, but I'm telling you right now, it's going to be very necessary in just a couple slides here. Okay, but what's 7 plus 2? 9. What's 1 plus 14? 15. What's negative 1 plus negative 14? Oh, and what's negative 7 plus negative 2? Which one of these would be valid for this problem? The 9. So you know what fits in those 2 spots? Positive 7. Oh, okay, work on my positives. Positive 7 and positive 2. Those are the only 2 numbers that fit. What's 7 times 2? 14. What's 7 plus 2? 9. That's the only thing that fits. This is your factor and you're done. That's the answer. You factored it. Okay? I'm going to do it again. But this time, I'm going to be a little bit trickier. You do it. Actually, you do it. You do it. I think you guys can handle it. Okay, is this a trinomial? Standard form? It's possible to be factored. It's possible. Probably. Maybe? Okay, I'm going to ask one of you in just a moment to give it to me. I already know it's going to be x and x. Think. No decimals. No fractions, no decimals. Because then, honestly, if you went fractions and decimals, not only will every one have an answer that's decimal or a fraction, but you can have an infinite, possibly, number, and that's not cool. Not gonna do that. Okay, let's see. Natalie, what'd you try? Just tell me what you tried. So here's how I really show my work from here. Like for me, if I'm still struggling, I just write 1 and 7. What's 1 times 7? 7. What's 1 plus 7? 8. Oh, that doesn't work. Give me another choice. There's another choice. It's there. I have it. Yep. Andrew? Negative 1 and negative 7. That does get me positive 7, but that gets me added together. Oh, negative 8. Is there anything else? Come on. Anything? No. You know what we put? Prime. It cannot be factored anymore. Prime. Did anyone come up with one and you thought, wait, I had it? That happens, by the way. Just check it. Just use your FOIL and you realize, oh man, it doesn't give me 5x in the middle. So you try something else. And if nothing else works, it's got to be prime. So are all trinomials factorable? No. Are most trinomials factorable? Yes. For you, they will be factorable. So don't put prime on everyone. It's not going to happen. Okay. Try this out. I want you to do it on your own. And I'm not helping you at all. I'm done helping. And I say that and then I start helping you. But no, this is you. That's what someone's been doing to me. So think of two factors. Oh, I'm helping you. Oh. Think of two factors of 42 that add up to be negative 13. No, that's not possible. Can't happen. Okay, I'm going to tell you right now it's not prime. It is factorable. There is a solution. Okay, how many of you have a solution? You have an answer here? Okay, I'll give you more time. Now, I want you to foil your solution to see if it's right. Someone in 8th grade said, Mr. A, are you saying that all of these problems, like we should not miss any of these problems? I'm like, yeah, all of these should be correct. Because you can all check them. All of them can be checked. And you already know how to multiply binomials, so that's not a problem. Okay, I'm just going to start calling on people. Hagen, what goes in the first spots? Nice. All right, so hopefully you guys are good at that. Eva, what did you try first? Like, I want you to tell me what you tried first.
7 and 6.
All right, 7 and 6. Does that get me 42 when I multiply? Yes. But what's 7 plus 6? 13. I got it. No, what do I need? Negative 13. So you're good. What did you try next?
Negative 7 and
negative 7 and negative 6. Okay, is negative 7 times negative 6 positive 42? Yes. Is negative 7 plus negative 6 negative 13? Yes. That's the last two spots. There you go. That's it. Yes, ma'am?
In like our answer, does it matter? Like, because for the answer, I put negative 6 in the first.
So you put negative 6, negative 7 there?
Yeah.
Okay. Does that matter? Why not, Natalie? Your classmate said no. Because of the community property. It's like you just switch these up, and that's allowed. Good. All right, but you know what? You know how many possibilities there were on this problem? How many of you tried 2 and 21? Okay, that would have given you 23. How many of you tried 1 and 42? That's 43. You could also try the negative versions, and you would have got negative, negative. So how many possibilities were there? Several. What I'm trying to tell you there is it's not always straightforward. Some of you, like you went through that, you got this, and then you're like, nope, it's that one. Great. But sometimes you got to keep going and say, wait, it's this right here. Or it's negative 2 and negative 21. So please don't give up. There are factors. You just got to think a little bit more through it. Okay. Just when you thought it was easy. Uh-oh. Let's do this one together. I'll make you do another one on your own. And then I think we're done. Okay, ready? Is this a trinomial? No. Do you notice I keep saying the same things? You know why Mr. A repeats himself? Because he's trying to do what? What do you think?
Make it clear.
Make it clear, emphasize, stress something. And the stress is that a trinomial? And the answer to that is yes. Is it in standard form? Yes. Now I can try to factor it. What goes in the first spots? N and N. So it works for other variables too, not just X, not just A, M, Z, Y, doesn't matter. It works. Okay. Yes, ma'am?
Well, I know that M and N makes N squared, but what happens to negative 3 N with the N with the negative 3? Does it... I've been confused what happens to that.
Gotcha. Like it seems like we're just paying attention to that and that. But then how do we get this?
Well, the n, like the other n, I don't know what happens.
This one?
Does it fit into the, yes.
Yeah, so remember, we're trying to find two factors of negative 18 that add up to be negative 3, so we deal with the numbers. And then this n comes naturally. You remember FOIL? Remember O and I? They both have an m. And those two added together get me negative 3m. So we're not super stressed out about it, but they don't, it doesn't just disappear, it's there. And we'll prove it again. Jackson, what'd you try first? Good. All right. Great. I would have tried 2, -9. I would have thought, what's 2 times -9? Negative 18. But what's 2 plus -9? Negative 7. Oh, that's not it. Who else tried something that's not the answer? Did anyone else try something else?
Oh, that's not the answer.
That wasn't the answer. Yeah, and you're okay to admit it. I'm okay to admit it. I actually tried 1 and negative 18. And what did I get when I add those two? Negative 17. That wasn't it. Anyone else try something? Not afraid to share it? No, Mr. A. I got it right the first time. Okay, great. That's cool. But if not everyone gets it right the first time. Michelle, what did you try? That wasn't the answer. Yeah.
I did 16.
Okay, 6 and... did you try 6 and just 3? Okay, ready? 6 and 3. Is 6 times 3 negative 18? So we can't try that out. But I'm glad you told me, because people are going to try that out on another problem. You got to try either negative 6 and positive 3, or negative 3 and positive 6. Okay, what's the answer though? Negative 3 and negative 6, or positive 6? Okay, I think this is my answer. I'm so sure of it, because it looks so good. Okay, ready? M squared plus 6m minus 3m minus 18. Add these two like terms, I get m squared plus 3m minus 18. What do you think? What? I got m squared and negative 18. What's your problem?
It's not negative 3m.
Oh, the signs. I can't stand the signs. Okay, fine. I wish we can go back. Okay. What is the answer then? Negative 6 and positive 3. I don't know about that one. I just tried that, didn't I? Didn't I just try that? Does it matter? Do your signs matter? Yes, they do. Because what's 3 times negative 6? Negative 18. That works. What's 3 plus negative 6? Oh, that's the answer. But Mr. A, all I did was switch the signs. Well, do you get the same answer when you switch the signs? No. Sorry? You don't get the same one, so you got to make sure you get that correct sign, which could be tough. All right. How many are? A lot of people are missing. I'm going to go with 5 of you need to get this one right. 3 of you. Sorry, 3 of you. I'm just kidding. 13 of you need to get it right. Like, Mr. A, what are you going to give us? That. And don't call it out. Just write your answer down, circle it, and you're done. And I'll give the answer all together. And remember, guys, think. Don't just think, oh, no, it can't be. Boom. Okay. Don't give up is what I mean. Try again. Got it. All right, who has it? Wait, I thought you guys got it. Who has it? Some of you dropped the pencil and you're like, I got it. So tell me what it is. Yep. Excuse me? Okay, what did you try?
5 and 1.
5 and 1. That gets me 6. All right. What else did you guys try? Negative 5 and negative 1? All right, that gets me negative 6. Ugh. Anything else? Water. Prime. But doesn't... Okay. There aren't many primes in your homework, trust me. But there could be, and you need to be ready for that. Ooh. How many of you are okay with this? And you know what happens? As you keep doing these problems, you get quicker at them, but it takes time. It's okay. If you don't get these quick, please ask questions. I'll help you out. 12 to 28 even. Page 159. Bye, Swivel.